GISP Unofficial Study Guide, Section 2, Geospatial Data Fundamentals. Section 201, Understanding Spatial Data Models and their Associated Planar Geometries. A spatial model has the basic properties and process for a set of spatial features. According to Bolstad, the cartographic model is temporarily static, combined spatial datasets, operations and functions for problem solving. Spatiotemporal models, dynamics in space and time, time-driven processes. Network models, modeling of resources, flow and accumulation as limited to networks. According to Goodchild, data models, entities and fields as conceptual models. Static modeling, taking inputs to transform them into outputs using sets of tools and functions. Dynamic modeling, iterative sets of initial conditions apply transformations to obtain a series of predictions at time intervals. According to Demers, based on purpose descriptive, passive, description of the study area, prescriptive, active, imposing the best solution. Based on methodology stochastic, based on statistical probabilities, deterministic, based on known functional linkages and interactions. Based on logic inductive, general models based on individual data deductive from general to specific using known factors and relationships. The vector data model. The vector data model is a coordinate-based data model that represents points, lines, and polygons. Points are discrete locations on the ground. They are represented by a coordinate pair. Lines are linear features, such as rivers, roads, and transmission cables. Lines are composed of vertices. They begin and end at vertices. They are represented by an ordered list of vertices. Polygons form bounded areas, such as islands, landmasses, and water features. Polygons are composed of nodes and vertices. The start node is the same as the end node. Attributes can be associated with each feature type. The raster data model. The raster data model is composed of rectangular arrays of regularly spaced square grid cells, and each cell has a value or attribute. Examples include soil pH, elevation, salinity of a water body. Raster datasets can have single or multiple bands. Each cell has one attribute value. Raster coordinates are stored by ordering the matrix. A pixel is the smallest resolvable piece of a scanned image. A pixel is always a cell, but a cell is not always a pixel. A geodatabase is an object-oriented spatial model that can include feature classes, feature datasets, non-spatial tables, topology, relationship classes, and geometric networks. Geodatabase basic components include feature classes, feature datasets, and non-spatial tables. Complex components include topology, relationship classes, and geometric networks. Relationship classes model real-world relationships that exist between objects, such as parcels and buildings. A grid consists of parallel and perpendicular lines for reference as a map projection or coordinate system. A tin, or triangulated irregular network, portions vector data into contiguous, non-overlapping triangles. Tins are created by Delaunay triangles. Advantages of a tin: small areas with high precision elevation data. Tins are more efficient, use storage space more efficiently than a DEM or contour lines. Disadvantage of a tin is that it requires very accurate data source and costs are expensive. Tin production and use are very computer intensive. Topological means features need to be connected using specific rules. Hierarchical means the database that stores related information in a tree-like structure. Records can be traced to parent records to a root record. A network is a collection of topologically connected network elements, like edges, junctions, and turns. Each element is associated with a collection of network attributes. An object-oriented data model is a data management structure that stores data as objects or classes instead of rows and tables as a relational database. Examples include SQL Server, Oracle, and PostgreSQL. A Euclidean plane. A Euclidean plane is a Euclidean space of a dimension of 2. It is a geometric space in which 2 real numbers are required to determine the position of each point. It is an affine space, which includes in particular the concept of parallel lines. A Euclidean plane with a chosen Cartesian coordinate system is called a Cartesian plane. Section 202, Understanding of Spatial Data Relationships. Types of relationships. A one-to-one. Each object of the origin table can be related to 0 or 1 objects of the destination table. One-to-many. Each object in the origin table can be related to multiple objects in the destination table. Many-to-many. Multiple objects of the origin table can be related to multiple objects of the destination table. Equals. A equals B means they are topologically equal. Disjoint means they have no point in common. Intersects means they have some common interior points. Touches. If A touches B, then at least one boundary point is in common but no interior points. Contains means feature B is within feature A. Covers means every point of B is a point of A. Covered by means every point of A is a point of B. Within means A is within B. Crosses means A crosses B at some point. Overlaps means A and B have common interior points. Basic topology rules. Polygon rules. Must be larger than cluster tolerance. Must not overlap. Must not have gaps. Must not overlap with. Must be covered by feature class of. Must cover each other. Must be covered by. Boundary must be covered by. Area boundary must be covered by boundary of. Contains point. Contains one point. Line rules. Must be larger than cluster tolerance. Must not overlap. Must not intersect. Must not intersect with. Must not have dangles. Must not have pseudonodes. Must not intersect or touch interior. Must not intersect or touch interior with. Must not overlap with. Must be covered by feature class of. Must be covered by boundary of. Must be inside. Endpoint must be covered by. Must not self-overlap. Must not self-intersect. Must be single part. Point rules. Must coincide with. Must be disjoint. Must be covered by boundary of. Must be covered by endpoint of. Point must be covered by line. A spatial relation specifies how some object is located in space in relation to some reference object. Section 203, Understanding of Data Quality. Geometric accuracy. Geometric accuracy is the closeness of a measurement to its true value. The root mean squared error. The root mean squared error is a calculation to describe the difference between the measurement and the true value. This can apply to georectification. The root mean squared error is the square root of the average of squared errors. Thematic accuracy is the accuracy of the non-spatial data, such as is the street name accurate on a street feature class. Resolution. Resolution is the smallest separation between two coordinate values. For rasters, this refers to cell size. Precision. Precision is the level of measurement and exactness of attribute data. Fitness for use. Does the data fulfill the needs of the project? Confusion matrix. Assesses accuracy of image classification based on additional ground truths. Quality assurance. Quality assurance is process-oriented and focuses on defect prevention. The establishment of good quality management system and assessment of its adequacy. Periodic audits is a managerial tool. Quality control is product-oriented and focuses on defect identification. Finding and eliminating sources of quality problems through tools and equipment. Quality control can use corrective tools. Imprecision. All data is taken from a 3D globe and transferred to a 2D surface through spatial transformations, projections, and datums, which cause distortions with the data. Uncertainty. The GIS data was created or collected at a certain point of time and may already be out of date. The root mean square deviation, or the root mean square error, is used to measure the differences between values predicted by a model or an estimator and the values observed. The root mean square deviation represents the square root of the second sample moment of the differences between predicted values and observed values, or the quadratic mean of these differences. These deviations are called residuals when the calculations are performed over the data sample that was used for estimation, and are called errors when computed out of sample. The root mean square deviation serves to aggregate the magnitudes of the errors in predictions for various data points into a single measure of predictive power. Accuracy versus precision. Accuracy is the degree to which information on a map or in a digital database matches true or accepted values. Precision refers to the level of measurement and exactness of description in a GIS database. Quality assurance versus quality control. Quality assurance is a set of activities for ensuring quality in the processes by which products are developed. Quality control is a set of activities for ensuring quality in products. The activities focus on identifying defects in the actual products produced. Section 204, Understanding of Data Resolution. Data resolution, the cell size of a raster, the area covered by the ground represented by just one cell. Scale, accuracy, and resolution in a GIS. Map scale. The map scale specifies the amount of reduction between the real world and its graphic representation. It is usually expressed as a ratio or equivalence Display scale. The display scale of a map is the scale at which it looks right. Data accuracy and uncertainty. Data accuracy is a statement of how closely a bit of data represents the real world. Data resolution. Data resolution is the smallest difference between adjacent positions that can be recorded. Since a paper map is always the same size, its data resolution is tied to its scale. Resolution also limits the minimum size of a feature that can be stored. Raster data resolution. Raster data is stored as pixels, which form a grid or mesh over an area of the Earth. The size of these pixels determines the resolution of the raster because it is impossible to store anything which falls between the pixels. Data density. Data density is a measure of how many features per area are stored, and may imply a minimum feature size. Greater density implies more features in a given area, and therefore the features may be smaller. Data detail. Data detail is a measure of how much information is stored for each feature. Generalization. In GIS, it is possible to create a new coverage by reducing the amount of detail in existing coverage. This generalizing may or may not reduce the number of objects in the coverage. Section 205. Understanding of data validation and uncertainty. Uncertainty is differences between the real world and GIS. Uncertainty may be visible from the original data or measuring that data. Assumptions may be made when creating the data. Model structure, retrieval errors, sampling errors, and inadequate ground observations. Validation is to ensure the accuracy of the data is preserved. Ground observations ensure data accuracy. Validation can also be compared to model-generated data, but less accurate. Section 205, Supplemental, Understanding of Data Validation and Uncertainty. dusk.geo.orst, Chapter 6 Notes, PDF. Uncertainty. Uncertainty in geographic representation arises because almost all representations of the world are incomplete. Uncertainty arises from the way that GIS users conceive of the world, how they measure and represent it, and how they analyze their representations of it. Vagueness and ambiguity. Vagueness is uncertainty that can exist in the positions of the boundaries of a zone and in its attributes. Ambiguity is introduced when imperfect indicators of phenomena are used instead of the phenomena themselves. Object names and the topological relations between them may thus be inherently ambiguous. Direct indicators and indirect indicators. Direct indicators are deemed to bear a clear correspondence with a mapped phenomenon. Indirect indicators are used when the best available measure is a surrogate link with the phenomena of interest. Concatenation. Concatenation is used to describe the integration of two or more different data sources, such that the contents of each are accessible in the product. Conflation. Conflation attempts to replace two or more versions of the same information with a single version that reflects the pooling or weighted averaging of the sources. Uncertainty and error in GIS and geographic data. Data quality. Data quality describes the overall suitability of a dataset for a specific purpose. Data quality can include error, accuracy, precision, resolution, generalization, complete, compatible, consistent, and applicable. Accuracy and precision. Accuracy is the extent to which an estimated value approaches its true value. Precision is the recorded level of detail in the dataset. Generalization. Generalization is the simplification of real-world features. Features need to be generalized because data are required at a certain scale. Types of generalization. Selection. Selecting the real-world features to be included in the map. Simplification. Features are altered in order to enhance visibility and reduce complexity. Displacement. Altering the location of overlapping or adjacent features in order to make them both visible. Smoothing and enhancement. Altering the jagged or rough edges of features in order to provide a better representation. Types of generalization. Selection, simplification, displacement, and smoothing and enhancement. Other characteristics of quality: completeness, compatible, consistent, and applicable. Completeness. Data must be spatially and temporally complete. Compatible. Multiple datasets used in the same project must be of the same format, scale, and extent. Consistent. Multiple datasets should undergo consistent methods of data capture, storage, manipulation, and editing. Applicable. Data must be suitable for the analysis or project. Epsilon bands. Epsilon bands represent widths of uncertainty of whether points fall within or outside a polygon. Uncertainty from vagueness. We are forced to take phenomena of continuous nature and impose a crisp representation. Thus, we ignore the inherent uncertainty present in space. Crisp versus fuzzy representation. Fuzzy sets provide a method for representing the continuous nature of spatial phenomena. Section 206, Understanding of Metadata. Metadata are information that describes the content, quality, condition, origin, and other characteristics of data or other pieces of information. The ISO 19115 is a standard of the International Organization of Standardization. The standard is part of the ISO Geographic Information Suite of standards. ISO 19115 and its parts define how to describe geographical information and associated services, including contents, spatial temporal purchases, data quality, access, and rights to use. The U.S. Federal Geographic Data Committee, FGDC, describes geospatial metadata as a metadata record is a file of information usually presented as an XML document which captures the basic characteristics of a data or information source. It represents the who, what, when, where, why, and how of the resource. Section 207, Knowledge of Temporal Data. Temporal is data that represents a state in time. For example, rainfall for one day. The world is constantly changing. A static map can only show one time period at once. Dynamic maps can allow a user to slide between different time periods to show changes. Multiple maps can be created to show the changes or somehow superimpose multiple time period pieces of data on a static map. Temporal GIS. Temporal Geographic Information System is an emerging capability in GIS for integrating temporal data with location and attribute data. Temporal data specifically refers to times or dates, enabling temporal visualization and ultimately temporal analysis. Temporal data may refer to discrete events, such as lightning strikes, moving objects, such as trains, or repeated observations, such as counts from traffic sensors. Temporal changes occur at different instants or periods of time and are recognized by changes in spatial properties and/or locations. A temporal GIS processes, manages, and analyzes spatiotemporal data, which is spatial data that changes across time and is part of the geographic movement. Section 208, Knowledge of Spatial Data Standards, including ISO, FGDC, and OGC. The Federal Geographic Data Committee, FGDC, who, what, when, where, why, and how. Include title, abstract and date, geographic extent, and projection info, attribute label definitions, and domain values. Content Standard for Digital Geospatial Metadata, CSDGM. ISO 19115 was developed for documenting vector and point data and geospatial services, such as web mapping, data catalogs, and data modeling applications. ISO 19115-2 adds elements to describe imagery and gridded data, as well as data collected using instruments, such as monitoring stations and measurement devices. OGC, OpenGIS Consortium, describes basic data model for holding geographic data. These are data file types such as KML. The Open Geospatial Consortium. The Open Geospatial Consortium, or OGC, is an international voluntary consensus standards organization for geospatial content and location-based services, sensor web and Internet of Things, GIS data processing and data sharing. Its predecessor organization, OGF, the Open Grass Foundation, started in 1992. From 1994 to 2004, the organization also used the name Open GIS Consortium.